Okay, good morning. So, so did you complete the Helm? Okay. So what about that Jenkins pipeline for Kubernetes deployment? Completed, right? Okay. Okay, then in that case, we will discuss today the monitoring system, the important one of your Kubernetes cluster monitoring system, metric monitoring system. So closely, 4 classes pending is regarding Kubernetes. So today, monitoring system and config and secrets, and tomorrow volumes, and after tomorrow stateless and headless service. Okay. So headless service topics we can discuss and we can finish the Kubernetes. And as I said, if you want me to explain any tool, just let me know. Otherwise, we can end the sessions. Okay, project. So I have prepared 3 projects. One already you are doing something by using Jenkins, and remaining 2 are regarding Argo CD only. That is front and back and DB also. I will show you how to implement that and all for one day. And that is the last day. So that project I will explain here only. And remaining project we have to do it. Both are same. There is no difference. Okay. The document, the preparation, everything done. It's a very easy process. You can easily understand also. So step by step process it is from the creation of EC2 instance to uh, okay, let me share my screen first. So if you ask me to share now, I will share today itself the document. If you want to start from today, at least it will take some time. After complete the sessions, if you start, it means maybe I will be available or not. I will at this time, right? I mean, in the class, Telegram, I will be available. So yeah, the things if you can see here, the IAM creations, the first from the scratch, everything starting from the scratch and the keys configurations. And this is my Terraform code to create main EC2 instance. Main EC2 me you can create by using manual processor, Terraform, whatever. But the reason the main instance we need to install all the tools, right? Sonar Cube and something and all. So in that case, definitely go for this approach. Easily we can install all the tools, Jenkins and all. Whenever you can create the EC2 instance, in this EC2 instance only Jenkins also I'm going to install. After creation of this server by using Terraform, the first step, so access the public IP of the server and Jenkins server 8080. You are able to inside of the Jenkins. In that, by using Terraform, you can create the EKS cluster. So that is different Jenkins pipeline. Creation of EKS don't add into your application deployment. Whenever EKS creation done by using Jenkins, your cluster is going to run. And then you can start your process, the main process. So the creation of applications, take any sample application from here, my GitHub, and write the pipelines for the deployment of front end and back end, different process. And we can give the configurations of your DB, and we can connect your DB. We can see the inputs, the inserted inputs from the front end. Like we can see, we can discuss in one class everything. Okay. But in that class, I'm not sure how to configure quality gates, so on or cube that you know, right? Finally, I will show how to deploy the application. I will show here, deploy the application. But in your case, you need to add each and every step. Okay. So I will not show here how to create IAM access keys and all again and again. That already you know, right? Directly I will start the process. My EKS already running. I'm not going to create from the Terraform again and all. Yeah. On-premises setup is not required. If on-premises setup means I need to install everything in on-premises, Jenkins, Sonar and all. Even your laptop, my laptop also not support. Anyway, the projects 99% all projects on cloud only, especially cloud manager. Uh, Remaining, I don't know that, but not recommended. So these are all the process, the ECR creation and from the scratch everything. When I say this project from the scratch everything. So the front end application deployment, the back end application deployment, the front end related pipeline here. After execute this we can see here this Jenkins output, the backend deployment, the backend pipeline. After deployment, we can see this output. So these configurations, these are all these configurations. After configurations done, directly you can copy paste the pipeline, you can run it. The pipeline already we have done. The last project, something we have done, right? So this is Argo CD process. Same, each and everything in the step-by-step process over there, you can directly go. And Grafana Prometheus I will cover today. Yeah. Okay. Anyway. So Grafana and Prometheus. Okay, so Grafana Prometheus is a especially monitoring tool of the cluster. You can configure this Grafana Prometheus for your EC2 instance also directly, no problem. In the cluster, we have a different pods, different nodes, different services. We can easily see in the dashboard of the Grafana how many pods are there in the workspace. What is the present load on the pod, present load on the node. We can see easily by using Grafana and Prometheus. So Grafana Prometheus, okay, let me write. It is a metric tool. Metric tool. Metrics monitoring tool. So we can configure to a cluster or EC2 instances also. So today is a Monday, right? So if I complete the sessions Wednesday, for example, I think it will not complete Wednesday, Thursday. Thursday morning, I will give the document to everyone, the project document and how from the scratch you can try now. Saturday, I will take the session again. So we can explain project again. If you are facing any issues and all, we can connect and we can close the issues. But you need to start the practice on Thursday. After Saturday session, again, you have if someone may miss and started again. Again, it's very difficult to take the session for them, especially. Otherwise, if you need 1 week time, let me know, no problem. I will give 1 week time and we'll connect after 1 week time. But if I give a gap, it's not good. 2 days is enough to complete this project, no problem. So whatever we discussed in the last 4 months, everything is there in that project. So how to create from the scratch, everything is there in the project along with the screenshots and commands also. You just follow that only. And once complete that project, the second project also ready. That project, I will create some errors wantedly. You need to clear that errors and complete the project. First project is for understand the approach in the real time, how we are going to create, how we are going to implement the project. The second project is for how you understood from this last 2 days, 120 days. That is very important. So from the IAM, I will create the error, and inside Kubernetes, I will create the some errors and everything I will cover, so that you need to rectify one and on each issue and complete and finally show the output. That is the agenda. Okay. Yeah. 2 projects for completely. I mean, database involved projects. Without database, so many projects are there. You can take it directly. So Grafana Prometheus is a monitoring tool, especially for, it is very helpful for if you configure the clusters. The reason the cluster contains multiple nodes, multiple pods, multiple components, especially those components we can easily monitor by using Grafana Prometheus. So for example, there is no any monitoring tool. You don't know the pod, the specific resource. Yeah. So you don't know the specific load of the load on the pod. You don't know the specific the CPU of the pod. So if you configure any monitoring tools, so we can easily open the monitoring tool. We can select the pod on the UI base. We can see the load. So no need to log in cluster. No need to go inside cluster. No need to give any commands to check. Directly, we can open the monitoring tool and select your workspace and which workspace pods are running and which node the pods are running. You can select, we can see the load directly. That is the advantage of Grafana and Prometheus. So here, so why Grafana Prometheus are two tools? It's a two tools. Why we are using two tools? Can we use Grafana only single or like Prometheus? The reason, for example, these are the nodes inside the pods. Okay, source. Okay, these are the source. In this source, from this source, okay, from this source, if I want to configure the, for example, inside pods are there, inside pods are there. In this source, this is cluster or EC2 instance. If it is EC2 instance, applications are there. Whatever, just assume it. So the Prometheus, the main role of the Prometheus is here, export the logs, metrics from here. So whenever you install the Prometheus, this Prometheus agent, so the Prometheus agent export the Prometheus agent export the metrics from source server to target. So my target is what here? Grafana. My target is Grafana here. So the reason here, Prometheus will do everything Prometheus only here actually. The node exporter and export the metrics from your source to target. So first, what I need to do here? So you need to install the source agent, Prometheus agent inside your nodes. Then only Prometheus can grab the metrics from the source. And in this Prometheus, if I configure any target, so here my target is Grafana. This Grafana collect the metrics. Grafana collect the metrics from the Prometheus, and it will show and it will give the result in UI format. Understand? So this Grafana will give the UI format of your logs. I mean, when I say It's not application logs, metrics. So here we need to understand one thing. These metrics, there is no any dashboard from the Prometheus end. That's what we need to take in a dashboard monitoring tool help here. Prometheus is collect the metrics, but unfortunately Prometheus, there is no dashboard to give the result of the metrics into UI format. In that case, definitely we need to configure Prometheus with any other tool, that is Grafana. So here the source of the metrics is Prometheus for the Grafana. And actual the metrics we can collect from the nodes by using Prometheus. I mean, by using Prometheus, we can collect actual the metrics from the nodes and pods. But that metrics, the Prometheus will not give any result back in the UI format. There is no dashboard for Prometheus. So that's what we can configure the Prometheus into any dashboard visual tool, that is Grafana. Is that clear? We can see the metrics in the Prometheus also, but there is a big difference for the Prometheus and Grafana to see the difference. The reason the Grafana, the very beautiful UI we can see here, we can select the respect to pod, respect to node, so many options are there in the Grafana. But Prometheus we are using for only here, collect the matrix from the source server. Okay. And the same thing it will apply for Grafana, will not collect any metrics from source directly. The input of the Grafana is Prometheus. The input of the Prometheus is the source of the nodes or pods. Is this clear, everyone? Yeah. Yeah. So now, let's go to Mumbai. What happened to my laptop? It's not. Okay. So I'm in Mumbai, EC2 instance. So yeah, connect to this server. I think this server, test. Okay. Okay. Yeah. kubectl get nodes. 2 nodes are running, right? Okay. So kubectl get pods. So only MySQL pod is running. It's a different one. You just leave it, no problem. So now here I'm going to install Grafana Prometheus on this cluster. Okay, on this cluster. So to install Grafana Prometheus, we are using Helm. Helm repos already stored as we discussed, Helm is the repository we can it will contain some AML files. Yeah, so it will give the Helm install process. It will apply for everything, right? The same thing if you can go for okay, I will open my here the so Grafana Prometheus. This is my cluster, right? This is my cluster. So Prometheus is here, Grafana is here, API client. So Prometheus will collect the metrics and give to Grafana. Okay. So these are different things. Just how to push the metrics. So there is internal network how it will work. If you want to focus, you can. Otherwise, leave it, no problem. So first Prometheus server, go to Kubernetes and collect the metrics. Okay. And we can configure to any email also that configurations and all. otherwise not required. And after that, it will give to the Grafana. Grafana, we can see the difference, the load and all. Okay. So this is internal Prometheus server, not required to go in that depth. So just we can understand only. The finally what we can understand, it will push the metrics and it will give it to the Grafana handover to that. So now if you can see here, so the prerequisites T2 micro, Helm, Secure group, whatever. So in your Helm is there, no, not required to install again. This is the process to install Helm again. Okay. So we have already installed Helm yesterday class, right? So if you want to install again, we can install from here. By using Helm, we are installing Grafana and Prometheus. Okay, and go to there, the second step. So chmod to read that helm.sh. And whatever, this is the installation process of Helm. Just no need to focus, just how to install only. Okay, Helm 3.15 version is there in my end. So the next process is why use Helm is a package manager of Kubernetes. Helm specify installation of all components. So in that components, we can install everything by one step only. So Prometheus is a open source monitoring tool, provides out of the box monitoring capabilities for the Kubernetes, collects and store the metrics, and it will give to the Grafana is a open source virtualization analytics software. It allows to query virtualization alert on the explore your metrics no matter where they have stored. Okay, so it will just give the visualization analysis of the your pods and nodes by using Grafana. But Prometheus is a metrics collection. It will collect the metrics, and when we configure the Prometheus, Grafana will give the visualization output of the matrix. Okay. So this is the first step how to install the. So I'm installing here. If you can see here, we need to add the Helm stable charts for your local client to execute the below command. Okay. I'm just adding the repo here to installation of Helm. We have a different process how to install Helm. I'm sorry, the Grafana and Prometheus. Okay, already exist. So Helm repo add. I mean that repo I'm going to add this Helm charts. In this Helm charts, the Grafana Prometheus configured YAML files will be there. Okay. Once you configure, what I need to do, I need to install directly. Okay. So first I'm going to create a namespace for Prometheus. I'm going to install Grafana and Prometheus in this namespace only. Already exist. Very good. Let me check in that case any pods are there. kubectl get pods. How to check specific path? Specific namespace? -n Prometheus. Okay. Oh, kubectl. If I delete namespace, will it delete all or not? Hmm? Okay, cool. Give the same command. No pods are running here. Everything deleted. So now my namespace is ready. If you can see here, after that, Helm install command. What is the install command? Helm install command. What it does? It will apply, right? So in your repo already added all the YAML files. Helm repo added. Helm repo added means the required all YAML files added in my Helm repo, and install on top of that your repo the YAML files, whatever YAML files added into your repo, it will apply. Is that clear? Yeah. Yeah. I'm going to install here. Install means apply. In this namespace, in this this tag, everything is added in the form of AML files. Prometheus is not found. Oh, I'll delete it, right? Namespace. Okay. kubectl create ns. Will it take? I can install. So in my GitHub, there is a one more process to install. You can go that process also, no problem. Okay, let me first check this. If it will not work, we can go for that process. Sometimes your Helm version may not support of your these installations. So if you get any that kind of errors, you need to upgrade the Helm version. If it is any old version, new packages may not support for your old version, new packages. In that case, you need to upgrade the version. See, after Helm install, we can see this message, right? Same now we're seeing means I'm just install the monitoring tool in the form of AML files. Okay. So now how to check kubectl get pods. So it should be run all pods. Only you can access your Grafana and Prometheus. Okay. Otherwise it will not work. If it is anything is pending in your workspace, it will not work your Prometheus and Grafana. It should be run first. In that case, maybe in your case, if you forget to delete the existing pods, the node's already busy with your existing pods, right? In this case, additional pods may not, your node will not support to schedule or pods. In that case, you need to delete your pods and rerun the command. Okay. Okay, now, so my pods are running. The unfortunately, if you can give the kubectl get svc hyphen Prometheus, I can see my service, right? Oh, sorry. kubectl get svc hyphen n Prometheus. Okay. If you can see here, okay. All are cluster IP, right? But how I can access cluster IP? See, if I want to see my Prometheus or Grafana, definitely I need some UI. I need to access some using some node port or load balancer, right? But here, all are cluster IPs. So we can go through my blog also. I can just above command used to install kubeprometheus tag the Helm repo. Everything I have updated here. To check whether Prometheus install or not using the below commands, just now we have verified that. Same like SVC. Grafana will coming along with the Prometheus as a stable version. Okay, no problem. This output is confirmation that our Prometheus is installed successfully. So my end also I can install everything. It's running. Okay. There is no need to installing Grafana and separate tool. It comes along with the Prometheus, a stable version. Let's expose the Prometheus and Grafana to the external world. There is a two ways. One is node port, one is load balancer. Let's go with load balancer or let's go with node port also. So if I go for load balancer, anyway, any process, we can give the edit command, your service edit command. In the YAML file, you can change load balancer or node port. So let's run this command first. We can decide which option we can expose here. Excuse me. So go to page here. So click means it will page will open. This is the actual YAML file to expose your service. So my service is there in the cluster IP. If you can see here, a Prometheus service exposed into the internal only. So it's cluster IP. What I can do here, I can give node port and just WQ. It is edited. So now again, you can give the service Prometheus. Sorry. Yeah. This time we can see node port. Okay. So how to access the Prometheus, guys? kubectl get nodes -o wide. So you can take any one of the external IP. Why service will work cluster level, not node level. So, and port is 32526. Yeah, this is Prometheus dashboard. But this dashboard is not at all helpful for us to check the Prometheus, nodes and pods. It will give the result into the some matrix format, some query format. The query we cannot understand. So for example, just keep as is. We can run Grafana also, then we can check command here and check. Okay. So go to my here. So after change the cluster IP to node port or load balancer, your wish. My blog is there, node port. I'm doing here node port. Change it from cluster IP to node. Okay. And you guys can see the load. Okay. So now, so if you can go again for this process also, let's give a minute. Yeah. So, and again for Grafana, I'm going to edit the Grafana SVS file. So Grafana SVS file is this one. Paste it. Okay. Stable Grafana. Where is the stable Grafana? Sorry, in the pods. So this one. Okay. Stable Prometheus already exposed. It is running on node port. Same Grafana also I'm going to expose. Different service files. Grafana, see if you can see the pods. Grafana pods are running. Prometheus pods are running. So Grafana pods, we need to expose through Grafana service. Prometheus pods, we need to expose through Prometheus server service. So Prometheus service already exposed through node port. Now Grafana service I'm editing and I can expose through load balancer or node port. Again, my wish. So if you can see still cluster IP for Grafana also, I want to change node port a load balancer. Load balancer is a costly, right? Chargeable. Okay, edited. Again, kubectl get svc hyphen and Prometheus. This time I can see two node ports. One is for Grafana, one is for Prometheus. Prometheus I'm able to access. Now Grafana I need to access, right? So the node is common, right? Control C. So the port number is 3106, I think. 3106. 3106. Wrong port. Let's go and check. 31606. Sorry. Okay. So my Grafana dashboard, this is. Okay. Same username, password. The username is admin. Password we need to take from there again. Okay. So again, go to my blog here. So kubectl gets secret, and in this path we will get the password. Echo means print the password. Prom operator is my password. We can forget your password. You can change your password if you want to change. Never. Okay. This is dashboard of Grafana. This is dashboard of Prometheus. Is that clear, everyone? These configurations are one-time configurations. Don't think much how to automate this process. See, always as a DevOps engineer, we need to automate the regular process, not for one-time process. Application deployment. These are we need to think about how to manage the automations. This one-time process, you can go with manual process or automation process. So simple. These two we can this URL we can paste it into any .ssh file. .sh file. You can run the file name following the shell script sh dot the file name. It will install everything on the one step that already I have done in the project. You can go same process or manual process. Anyone is recommended, no problem. No one can object you. The creation is only one time. Enter your cluster. Okay. So this is the dashboard. Yeah. So this is the dashboard of Grafana. So what I need to do, you can go to dashboards. Same thing I have updated in my here also. Go to welcome to Grafana and go to dashboards and import. We can start the process. Okay. So yeah, go to dashboards and click on new here and import. Same thing in my blog also there. Import. Okay. So here import. Maybe the UI change a little. Before is here, now here. Click on import. Okay. And again, same block after import. So, okay. Yeah, 15760. Okay. So I will tell you one thing here. These IDs, okay, 12740, 15760, 1273, something, some IDs there, right? These IDs, different UIs. I mean, the background, this ID already generated one query. Okay, the Grafana dashboard. If I give 12760, your UI different look we can get. If you give different code, we'll get different look we'll get. I mean, the process is same. If you give 12740, your pods we can see here. Your nodes we can see here. If you give different ID, your pods may you can see here. Nodes we can see. I mean, different code, different UI. But the process is same. Okay, sir, who can develop this? Provider can develop. You can develop your query also. That is developers can write. Okay, not you. They will generate the some query and they can map it with some codes. That code you can configure means we can easily configure your queries. Okay. Anyway, leave about that queries and all. So we have a different codes, or your organization will give before they develop anything, they will give the code here. So if you can 15760 or 12740, all are same, but some UI only difference will be there. So after give the 15760, give the load button here. Import dashboard. So Prometheus. So yes, I need my Grafana output 15760 output means there is a different UI. Okay, where is your source? To print the Grafana output, where is your source? My Prometheus is my source. Select here. Okay, and import. So we can see like this. So my Prometheus will configure to Grafana now. My Prometheus already, whenever you run the pods, right? The pods will collect the metrics from all the your nodes and pods, internal cluster. If you install in the internal cluster, right? So now we can see here, data source is a Prometheus, cluster is none, namespace is default, pods are all, resolution is 30 seconds, job is a cube state matrix. This is fixed, you can change it. Namespace, we can see different namespace. I mean, my pods are running Prometheus. If you can select the Prometheus pods, see, I can see some differences here. So for example, total pod RAM. So this is my total pod RAM. Okay, you can share to anyone, you can download and we can do anything. If you can see here, these are the present load, minimum, maximum of CPU of your container. So memory usage of your container. This is memory, this is CPU. So here we can see the network bandwidth, the network. So these are all related to metrics only, not for inside application logs. Metrics of your network inside the pods and something. If any packet is dropped, we can see here. Okay. For example, now I can deploy any one of the pod. I can deploy any one of the pod. I can see here. For example, okay, Prometheus, right? If you select default, namespace. In the default namespace, one pod already running here. My pod IP is this one. Okay. So if you can see CPU used is 0.0035. Okay. Memory used is 373.24 MB. I'll just open that pod. I will hit again. We'll see the how the data will increase here. So the pod is running in which namespace? Default namespace. Kubectl get pods. So this pod, right? This pod is running. So I can increase the load on this pod. How to increase? We have a command, right? Yes, stress. We use horizontal auto scaling, the test.sh. I think my end already there, but notepad will change, right? Anyway, vi test.sh, paste. Okay. So here I need to give my pod service. This is load balancer. Yeah. I need to give what? My pod, internal pod service. So this is already running right here. Oh, okay. Okay, let me come back. Kubectl get svc. Yeah, my app np running on this node port 32247. So you can take the IP and give control C 3227. Okay. And let's go here and again test.sh. Nothing is there. Sorry. Again, I need to copy paste here. This one and go here. Insert. Go here. Paste. Okay. So I need to, what is the port number? 32247, right? Okay. 32247. Copy this here. Is that correct? 32247. Why it is coming like the different color? Anyway. So sh test.sh. Control C. Okay. I'll just copy this one only. Kubectl will get svc 32247. Correct only, right? Okay. Vi test.sh. Go to here and copy here. Paste it here. We did correct only, right? Okay. Take here. 13201 is correct. Sorry, that is not accessible. MySQL only. Okay, we can do one thing also. Why it is not exit? It's got stuck. Okay, so what I can do now, we can verify so many ways. ls sudo su-hyphen kubectl get nodes, yeah, kubectl get pods. Okay, so I will deploy any one of the applications simply. Go for services. You can go for node port or load balancer also. Copy my service. So I'll just vi. So I create some workspace. Create test. Create ns test. Okay. So now vi test.aml. Paste this. Is there any workspace here? No, right? Nginx. Okay. Okay. So kubectl apply -f. So here, how to give the workspace? -n created workspace you can give. So it will deploy into the respective workspace. Kubectl get pods -n test. So 3 pods are running, right? You can go and check the workspace also here now. So just refresh here. So my workspace is what? Why it's not coming? Test. Okay. So I can see here. See, these are my pods. Just now I created, right? You can select, you can give all also, it will show here. So wait for 30 seconds or 1 second I can give and refresh here. Memory used is 12.41 MB. So I think no data, right? That's what it is showing, no data. So on the, no one can access my pod, right? So it's a zero load. For example, you can select here one pod. So the pod related information you can see. So this is the pod running on this node, which node the pod is running. Last terminated exit code, no, we haven't terminated any pod here. That's what no data. So CPU user is 000. There is no load on your pod. Memory user, internal memory use 3.93 MB. So you can see all are looks like plain only. The reason there is no load, right? So what I can do, I can increase the load now. So this is my pod, right? So go to services, ls vi test.aml. Otherwise, edit option also we can use. So node put already there. Okay, then in that case, definitely it will be created. Kubectl get svc -n test. Sorry, kubectl get svc -n test 30180. Three zero one eight zero. Okay, if we increase the load here or the okay, otherwise I will take from here. There is a script right in our end. So ls vi test.sh So insert, you can give, okay, HTTP missing. That's what it is not working. So SH, okay, this time is working. HTTP is missing in the before case. So now just increase the load, right? Increase the load means definitely here also we can see the difference of the, so after some time, see started load already here. Just refresh here. See, graph started from here. Here also. See here also. CPU 0.0002 now. Before is 00, all zeros, right? Now 002. So increase the load, increasing the load. Now 25. I can see, excuse me, I can see here, and this is one type of dashboard. So we can see here the graphs also started here also. My container load is increased. So this is one type of process, the one code. You can go for one more code. Go to dashboards, new, import. So now you can give different code 12740, different output, load, and source is what? Prometheus import. See this time different. I mean, what we can understand is total nodes. I can see here two. My total, the load three. Sorry, total required. I think cluster memory. Okay, 3.8 GB. So this is different. Nodes is highlighting here, but definitely everywhere, everything will cover. But the place and all it will be different. Here I can see that load and all. Here only the network and all. We can select here. So here there is no specific option to. Here the options are very less to select like before. So in the before I have selected different node, different pod like that. Here there is no pods option. Maybe you can select test namespace, all resources only. There is no here specifically could select one pod. So different, I mean, different node, different code, different output. So again, go to dashboards. Go to dashboards. You can discard it, import. Now again, you can see 3662. Prometheus import. This is different output. Okay. This is different output. But finally, what we can understand, we need to configure Prometheus into your cluster and there to your Grafana. So I have a one more approach. If you want to go with that approach also, you can go how to install and all. Monitoring. So first we need to install Prometheus or Grafana. So just 3 commands to install Prometheus and edit the service or Prometheus service. And different installation process, Prometheus and Grafana separately. And go for Grafana, install Grafana and expose node same like Prometheus. That's it. Two commands. This is a process how to follow. Okay. Any questions? So now we can easily check, right? The specific pod no load and specific node load. No need to go on inside the cluster and give the kubectl descript pod or kubectl top pod. Top command, we can see the load, right? Top command. Yeah. So in our project also I have configured Grafana Prometheus. If you can see here. Yeah. Okay. See, after Argo CD I have configured Argo CD, Argo rollout, everything we can see here. Is that clear? Okay. If you clear, I will start one more concept, config and secrets. Okay. So the concept is how to work with the database. Okay, in the Kubernetes. Same thing, we can take a directly my image, you can deploy it, one database will be created. Okay, MySQL image, MySQL database will be created. PostgreSQL image, PostgreSQL created. Mongo image, MongoDB will create. In the form of images, you can take it. But there is a separate process in the Kubernetes. Always, if you can deal with, okay, guys, you tell me one thing. In RDS, there is important topics, right? To how you can configure multiple, multiple users in the RDS. In RDS, there is no concept of no same no different duplicate nodes, right? There is a concept only in the RDS is what? Yeah, read replica and master and slave, right? Okay. So read replica and master node. Master only allow for write operations, read only for read operations. In that case, guys, you tell me one question to everyone. So this is my pods, right? kubectl, any pod you can take, kubectl get pods. Kubectl get pods, if you can see here, how many pods are running mine? One pod. So guys, if I delete my pod, if I delete my pod, you tell me same pod will be created or not? Depends on means the image is same, right? If I delete here, same pod will be created or not? It is in the deployment, not in pod.ml. Deployment. So 3 Nginx, for example, okay, let's go. ls. So test.ml is there. kubectl get pods -n test. I can see 3 pods. My replica is 3, right? If I delete one pod, what happened? This is called self-healing, right? New pod will create, same name will create, different name will create. Different name, right? Different name will create. So different name means if I'm talking about any backend application configuration for your database, okay, my database configurations I have created in my application in my application pod, it should be redirected to database, right? In the application, I have given this name as a configure name. I mean, endpoint means definitely your name also will come. The database RDS endpoint, whenever you give us some name to create RDS, right? In that case, the endpoint and your name, your port number, everything will come into your endpoint. So if the same thing here also, my endpoint, this name also there in my endpoint to connect my RDS. If you delete the pod, different name will come, right? Different name will come means your application will not interact. Understand the before backend application, front end, backend, and DBN, right? The backend, the name will change means definitely your backend application may confuse. My endpoint will change to send request to which database. There may be a confuse, right? So this condition in especially in Kubernetes, there is a stateful concepts. Okay. So you tell me, guys, what is the difference between stateless and stateful? Hmm? What is the stateless and stateful? Stateless and stateful. So stateless is nothing but it will not store any data. That kind of applications. For example, my Nginx, server is my Nginx I have installed, right, by using pod. My Nginx, it's not store any data, right, in that. Just there is a code inside. That's it. It will not store any data. It is a stateless. It will not maintain any state. What about DB? Stateful. It will store everything data, right? It's a stateful. So stateful, if it stores the data means if the delete the database, again, it will create same database name. It will not create different database name. It will create different database name. Again, your application configurations will change. To maintain the state, very important, to maintain the state in Kubernetes, in Kubernetes for the database, especially for the database, we are using stateful set deployment. not for deployment directly. In the place of deployment, you can use a stateful set. If you can give like this, what happened? Same name will come. For example, let's see here. This is Nginx deployment, right? This is Nginx deployment. Let's go there. So this is deployment. If I change with the stateful set, we'll see the difference. Stateful set. Let me check S capital, I think. Let's go to stateful set AML. Okay. That's what I will follow ChatGPT. You can give here also AML. Yeah, stateful set. Okay. Capital S and only one L. Okay. Stateful set. Yeah. See, if I configure my, you can see the difference. kubectl apply -f tester.aml and which space we have created this space. Okay. Okay. What is the issue? Error validating the data, stateful set, missing requirement field, service name in if you choose the ignore the error. Okay. ls, why it is coming? We haven't changed anything, right? Noteboard. Okay. Okay. Let me take stateful set nginx aml. Okay. Stateful set nginx replicas 2. Okay. Anyway, let me deploy this one in my end. Go there. So I think already is deployment is working this and maybe the issue. So mkdir stateful set cd stateful set. Okay. vi you can give state sfs stateful set dot aml. Okay. Aml. Okay. So you just go and paste it here and change the image here. Insert. Okay. Okay. Got it. Got it. So give a same. It will take latest image. No problem. So this is just same process like a deployment. There is no much difference. So now kubectl up kubectl get pods in the default we can see. So default only MySQL is running, right? I'm applying here only kubectl apply -f sfs.aml. So pod and service also created. No need to focus service here, only pod. kubectl get pods. See the difference getting pending kubectl. Okay, volume also there, right? Insert. Let's delete this. Yes, double D. If you can give double D, only one line we can delete it. Okay. But it should be in the not in inside mode. Double D. Hmm. Okay. So what I understand from this, volumes are important. The volumes class is pending. Okay, anyway, so what we can understand, let me show you now. Tomorrow class, I will show you. The pods are pending, right? Yeah. Web 0 is there, see here. So if you can go for stateful set, the name, what happened? Okay. Yeah. If you go for deployment through stateful set, you will get name like this way. Your name is web, actually. But here we will get 0, -0. If it two replicas, web 0, web 1, web 2 will come. For example, web 0 you have deleted. Okay. Again, web 0 will create. Web 1 will delete. Again, only web 1 will create. The reason to maintain the state of database. For example, so this is your read. This is your master. Okay. So master indicates always 0 here. For example, you have deployed MySQL database. MySQL database. The MySQL, if you go for stateful set. So you will get what? MySQL 0, MySQL 1. Yeah, MySQL 0 and MySQL 1, MySQL 2. Like that, it will as per the replicas. So we need to understand here. So guys, as we know, in the RDS always the write request will go to where? Master. Read request will go to replicas. But in this case, how I can define which one is the master, which one is the read replicas? Understand? Understand here. So in this case, so whenever you create a 0, 1, 2 MySQL pods, right? We need to configure something here to make it as a read replicas. So for example, 1 and 2, I'm going to make it as a read replicas. You need to configure something here in the Kubernetes. So this 1 and 2 convert as a read replicas always. And 0 always master. No need to configure anything. Now, if write request is coming from your application, the request will go to where? 0 only. And read all 1, 2 parts. It will go. There is no here replica concept, right? In the database. 1, 2, 3, 4, 5 delete means 1, 2, 3, 4, 5 delete. It is not like that. It's not a stateless. Stateless, there is no data stored inside. So that no problem. Any pod, any scaling, no problem. Inside application only there is no any data is stored. But DB is not like that, right? DB in the RDS class we already discussed. If I insert some data, my request will go to same data, same pod. If the request will go to different pod, in that pod my data will not there, right? It's a read pod. So how we can change read and write? So always 0 master, 1, 2 are read replicas. 3 pods you are creating means first pod is master, second 2 pods are read replica pods. You need to understand like that. If MySQL 0 delete, again MySQL 0 only will create. That is stateful set. In the deployment, if you delete MySQL 0, it will create any name, different name, not MySQL 0. So if you go with deployment.yaml, it will not maintain state. This is very important point. If you go for stateful set, it will maintain state. How it will maintain, I will go in depth for the tomorrow class. So yeah, of course, database stored in the pods. I mean, MySQL is a database, right? It's run as a pod. MySQL database pod means Same MySQL database. In this pod, see RDS simply we can say this is master, this is read replica. Same, but here master means master server. Master EC2 instance. We are unable to see EC2 instance. Why? This is managed service. We are unable to see read replica instances. Why? It's a managed service. In place of servers, same pods in Kubernetes. MySQL pod, read replica pod, read replica pod. Why? Your application pod redirecting to database pod. Which database pod? Master pod or read replica pod? The request is coming from the front end, right? The front end, we insert the record means it should be go for master pod, not read pod. If someone is accessing, the request will go through read pod. How I can configure? There is a configuration concept that is taken care by database team, not you. This is very clear. But what we need to understand here, database deployment, we should deploy into the stateful set, not deployment. The reason to maintain the state. Either if it is a go for deployment, if you delete Nginx or any pod, it will create one more pod immediately, but different name, not same name. Different name means state will not maintain. The front end configuration again will change. The before change, same here also same problem. To avoid that problem, always my request will go to MySQL 0. In that case, you need to deploy your MySQL into stateful set YAML to give the same definition. Clear? $100 down. 100% down, right? That's what we need to maintain different regions, high level, high availability. It is not easy to down applicate pod, right? We have to maintain different pods, right? Yeah. But master always one. Same thing. In RDS also master may down. There is no ways we need to promote read replica as a master. Same here also concept is there. But one thing I can say, just I'm saying here, 85% projects, they are using RDS. Again, front end and back end, front end, back end. This is front end, for example, any one of the programming language. Back end, any one of the programming language you are using. For example, here, Angular. Here, we are using Node.js. So the request is coming. This Angular is redirecting your request. React is redirecting your request into that application layer. And application layer should redirecting into database layer. So you can configure in the application pod. You can configure RDS also. There is no rule to use only pods. If you need more consistency, go for RDS. Understand? Go for RDS, but don't go for EC2 instance for web and applications. Understand? Web and applications go for pods only, Kubernetes only. But Kubernetes application pod, instead of giving your pod database endpoint, you can give RDS endpoint. I mean, whatever the request is coming, it will be diverting into your RDS, store the database. Understand? See if you can see stateful set. This is stateful set. That's what web 0, right? That is web 0. If I change to deployment.ml, this name also will change. Different name will come. Understand? Yeah. Okay. So definitely, if you run any pod of MySQL, inside definitely username password we need to configure, right? So if you create RDS database, we need to configure username password. Same in Kubernetes pod also, we need to configure username and password. So that is the concept of config and secrets. I mean, vi mysql.yaml. This is YAML file for deployment. Same deployment, there is no difference. But here the difference we can understand, volume section is added here. The volume section tomorrow I will complete. Before that, we need to understand here. What is this? MySQL secret, MySQL config, MySQL config, MySQL secret. Your DB, we have a username, we have a password, right? Instead of hard coding here, I'm calling from config map key reference. I'm calling from secret key reference. I mean, we have created 2 more YAML files. to call the secret, to call the config. For example, if you can see here, even tomorrow I will explain, don't worry. If you can see here, MySQL password. I mean, this is MySQL deployment. This is not stateful set. You need to understand one thing. When we can use for stateful set, your replica is more than one. Understand? If replica is only one, stateful set is required. Not required. Understand? Go with deployment. If you go for multiple replicas only, stateful set will require which is the master, which is the read replica to identify. If you only go for only one replica, in that case, go for deployment or stateful set. Both are same. There is no difference. If you delete pod means new pod will create whatever it is. If you can see here, I'm just calling MySQL. I'm just creating MySQL image container. So I'm calling MySQL direct image. Yes, you are taking image and create a pod. To log in that pod, kubectl exec-t pod name go inside container. If you go inside container, what you need to do? In RDS, once you create RDS, once you connect RDS, what you did in the time? Yeah, after connect the RDS, what you did? In the DB. Create a and tables, something, right? Here, how to create a tables in your pod? For that, credentials required, right? Username, password required, right? First, you are deploying a pod. To log in a pod, username, password required, right? That username, password, if you can see, two sections. You can go for default username, default password, or username. You can define your user and your password. Here, if you can see, I have written four environments. First one is MySQL root password. Second one is MySQL database. Third one is MySQL user. Fourth one is MySQL password. Here two users, MySQL root password is for root username. MySQL user password is for MySQL username, different username. Okay, but here not hard coding any password. Here not coding any hard coding any username. Is that clear? See, we need to understand. I'm calling from values from config map key reference. This is the name. This is the key. Let's go to config map key. You can easily understand. Don't worry. Tomorrow class also I will explain the volumes and this one. So cat MySQL. So take this copy enter from here. Just ignore volumes for today. So go to paint. Okay. So this is MySQL pod deployment. Okay. And I need to go here. ls cat config.yaml. This is just config.yaml. Copy. Paste. Yeah. So my config.yaml, if you can see, this is the users block. Where is the user? This is the users block, right? Okay. What is the name of MySQL? I don't know here. Here I don't know my MySQL username. Where you configure in the config map folder, in the config map YAML. What is my username here? Admin. My username is admin. Okay. Instead of writing admin here, I'm calling values from config map reference. So values from config map reference. Okay. In the config map reference, what is your name? MySQL config. Okay. What is the name? MySQL config. Okay. Which metadata, which name of your config map? This is kind. This is my config map YAML. Okay. In that, which username I need to select here? MySQL user. Okay. And the same thing, my database. If I want to call my database, same process. What is the MySQL database here? Is there, right? My database is in this block. In this database block, Values from config map key reference. I mean, same values from config map key reference. Inside which name? MySQL config metadata. Inside which database name? MySQL database. So here I'm calling here MySQL database key name. Same thing, secrets. Let's go to secrets. Cat sec.yaml. This is secrets. Copy. Paste it. If you can see here, these are my secrets. I have configured instead of hard coding into the YAML file. Yeah, see here now. Okay, so here, how many secrets I can see here? 2. One is for password and second one also password. Okay, first one also password, second one also password, but there is a difference here. This is root password. If you go for root admin name, admin means root username. Go for root password, this one. If you want to create a new username, you can write one more block here for username. Write config file for one more config, I mean, same config file inside the data block. You can write MySQL database. You can write MySQL user, right? You can write my user. Give the username. Give the one more user. Like list of users you can write here. That user you can call here. Okay. Now if you can see here, my password, MySQL password. This is MySQL password. Okay. In the MySQL password, if you can see, my key is what? MySQL user password. I mean, your MySQL user password is this one. This is which format? Encoded. We need to decode, right? We need to decode, actual password will come. But this password I'm calling where? Here. In the form of here config map, we are calling config map key reference, right? Here secrets we can call secret key reference. Take the secret key reference. There is my password in that. You can configure from there only. Here 2 secrets we have. See, one is for MySQL root password. One is for MySQL password. 2 different password. MySQL root password configure for, see if you can see MySQL root password configure for MySQL root password. See here. Key name is MySQL password. Key name is what? MySQL password. See if you can see MySQL password time. The request will go to here. MySQL root password time. The request go to here. This is root password. By calling everything is same. But here key name is what? This is the key name. Sorry. This is the key name. I'm calling only key names only. See, MySQL user key name. Okay. And MySQL user password key name. How to call secret reference? Secret reference. Which secret key reference you are calling? You need to define the metadata key. Understand? Like that we need to call config map and secrets. So tomorrow class I will explain in practical. We'll get a clarity. So tomorrow class is stateful set and config map secrets and volumes. So, and one more concept is there, RBAC, role based access cluster. That is one also very important. So many concepts are there in the Kubernetes. Okay. We can also configure all the values in YAML file also. Yes, you can configure. All the values means only image only you can call, right? Okay. So Grafana, Prometheus, please practice your end. There is a block my end also. So you just go through that block. You can easily configure Grafana Prometheus, and remaining just leave it. Tomorrow class I will cover stateful set and config map secrets and all. Okay. So don't skip the last 3 classes are very important, and coming 3 classes. Thursday may be the last class. Friday I will show you the practical. I mean one project in the live. Okay. Yeah. Okay, that's all for today. Log link. Which log? Oh, blog. Okay, blog. If you have any questions, you can ask me in the Telegram group. I'm just sharing the blog. Okay, this is the blog. Okay, guys, thank you so much. Bye bye.